Hello friends, welcome to the series of lecture of Mathematics 1. In a last session, we have seen some basic concept of partial derivative and higher order partial derivatives and some of the examples of partial derivatives. In today's session, we are going to take miscellaneous examples of a partial derivatives. Now starting with the first example, if u is equal to log of x cube plus y cube plus z cube minus 3xyz, then show that or prove that del by del x plus del by del y plus del by del z the whole square of u is equal to minus 9 divided by x plus y plus z the whole square. Now see, here del by del x plus del by del y plus del by del z the whole square of u does not mean that is equal to del u by del x plus del u by del y plus del u by del z the whole square. But you have to write down this in a form of del by del x plus del by del y plus del by del z the whole square of u is equal to del by del x plus del by del y plus del by del z of del u by del x plus del u by del y plus del u by del z. Now, what we are going to assume is del u by del x plus del u by del y plus del u by del z is equal to v. So, this term is going to be in the form of del by del x plus del by del y plus del by del z of v, where v is nothing but del u by del x plus del u by del y plus del u by del z. Now, first we are going to find the value of v, that means del u by del x plus del u by del y plus del u by del z. Now, since u is equal to log of x cube plus y cube plus z cube divided by minus 3 of xyz. So, differentiating u with respect to x, y and z respectively. So, del u by del x, that will be a log as a derivative 1 upon, so 1 upon x cube plus y cube plus z cube minus 3 xyz into derivative of x cube plus y cube plus z cube minus 3 xyz is nothing but it is 3x square minus 3yz. Same manner, derivative with respect to y will be 3y square minus 3xz divided by x cube plus y cube plus z cube minus 3xyz, and derivative with respect to z is 3z square minus 3xy divided by x cube plus y cube plus z cube minus 3xyz. Now, v is equal to del u by del x plus del u by del y plus del u by del z. So, putting the values of del u by del x, del u by del y and del u by del z and simplifying, so denominator is same, so LCM will be x cube plus y cube plus z cube minus 3xyz, and from numerator we are going to common out 3, so that will give you 3 into x square plus y square plus z square minus xy minus yz minus zx. Now, we are going to use the factorization. We are already aware of x cube plus y cube plus z cube minus 3xyz has a two factors, x plus y plus z into x square plus y square plus z square minus xy minus yz minus zx. So, if we are going to substitute this value in v, then v is going to be reduced in the form of 3 into x square plus y square plus z square minus xy minus yz minus zx divided by x plus y plus z into another bracket x square plus y square plus z square minus xy minus yz minus zx. So, x square plus y square plus z square minus xy minus yz minus zx will be cancelled out from numerator and denominator, and v is going to be a 3 upon x plus y plus z. We are going to substitute this value of v in original equation, that means del by del x plus del by del y plus del by del z the whole square of u is same as del u by del x plus del by del x plus del by del y plus del by del z of v, but v has a value 3 upon x plus y plus z. So, that will be a del by del x plus del by del y plus del by del z of 3 upon x plus y plus z. Now, if you are going to separate these terms, then you will have del by del x of 3 upon x plus y plus z plus del by del y of 3 upon x plus y plus z plus del by del z of 3 upon x plus y plus z. And since 1 upon x is a derivative minus 1 upon x square, So this is going to be in a form of minus 3 upon x plus y plus z the whole square, minus 3 upon x plus y plus z the whole square, minus 3 upon x plus y plus z the whole square. So it will going to be a minus 9 upon x plus y plus z the whole square. So please remember minus 1 upon x is a derivative minus 1 upon x square into derivative of denominator, but denominator is x plus y plus z. So if you are differentiating with respect to x or y or z, in each case it has a value 1. Okay. Now we are going to take one another example. See, if theta is equal to t raised to n into e raised to minus r square upon 4t, then find the value of n so that 1 upon r square of del by del r of r square into del theta by del r is equal to del theta by del t. That means we have to find the value of n such that this given equation is going to be satisfied. So first what we are going to do is, we are starting with a theta, and first we are going to find the right hand side, and then we are going to find the left hand side, and then comparing it we are going to find the value of n. So here theta is equal to t raised to n into e raised to minus r square upon 4t, correct? So differentiating with respect to t both side, so you have to apply the multiplication rule. First derivative of t raised to n, that will be a n into t raised to n minus 1, and e raised to minus r square upon 4t remains as it is. Then t raised to n as it is, and derivative of e raised to minus r square by 4t is e raised to minus r square by 4t into derivative of minus r square upon 4t. Now you are differentiating with respect to t, so minus r square by 4 remains constant, and derivative of 1 upon t will be minus 1 upon t square. So it will be reducing in a form of r square upon 4t, correct? So here it is r square by 4t. Now common out e raised to minus r square by 4t, so that will give e raised to minus r square by 4t into the bracket n into t raised to n minus 1 plus t raised to n into r square upon 4t square. Now this is your left hand side. Now we are going to find the right hand side. Sorry, this is your right hand side. Now we are going to find the left hand side. For left hand side, first we are differentiating theta with respect to r. We are starting with the innermost bracket, and innermost bracket has a value r square into del theta by del r. So first we are going to find del theta by del r. So differentiating with respect to r, that in that case t raised to n is treated as a constant, and e raised to minus r square by 4t has a derivative e raised to minus 4 r square upon 4t into the bracket derivative of minus r square by 4t with respect to r. So 1 upon 4t is remaining constant, and minus r square as a derivative minus 2r. So that will give minus 2r upon 4t. Simplifying this term, that will give you minus 1 upon 2 into t raised to n minus 1 into r e raised to minus r square by 4t. Multiplying both sides with respect to r square, that will give you r square del theta by del r is equal to minus 1 upon 2 t raised to n minus 1 r raised to 3 into e raised to minus r square upon 4t. Now differentiate this term both sides with respect to r. So differentiating with respect to r, so minus 1 upon 2 into t raised to n minus 1 constant. So it is constant, so we are going to separate it, and the in remaining part r square into e raised to minus r square by 4t, you have to apply u into v. So first r cube has a derivative 3r square, e raised to minus r square by 4t remains as it is. Then r cube remains as it is, e raised to minus r square by 4t has a derivative e raised to minus r square by 4t into the bracket minus 2r upon 4t, correct? So if you are going to simplify this one and then dividing with r square, that will give 1 upon r square del by del r into the bracket del r square del theta by del r is equal to minus t raised to n minus 1 upon 2 into the bracket 3 e raised to minus r square by 4t plus r into e raised to minus r square by 4t into the bracket minus 2r upon 4t. Now e raised to common out, and simplifying this term, that will give e raised to minus r square by 4t into the bracket minus 3 by 2 t raised to n minus 1 plus r square by 4 into t raised to n minus 2. Now we have given that 1 upon r del by del r of r square del theta by del r is same as del theta by del t. So putting both values of left hand and right hand, that will, and we are going to compare them. So that will give e raised to minus r square by 4t into the bracket minus 3 by 2 t raised to n minus 1 plus r square by 4 into t raised to n minus 2. This is same as e raised to minus r square by 4t into the bracket n into t raised to n minus 1 plus r square by 4 into t raised to n minus 2. So comparing both sides, e raised to will be cancel out, then r square by 4 t raised to n minus 1 cancel out from both sides, and then you are comparing, then you will have minus 3 by 2 t raised to n minus 1 is equal to n into t raised to n minus 1. So t raised to n minus 1 will be also cancel out, and you will have n is equal to minus 3 by 2. Okay, so this will give you the value of n, which we have to find out. Now we are going to start with another example. If x raised to x, y raised to y, z raised to z is equal to c, then show that for x is equal to y is equal to z, del square z upon del x del y is equal to minus x log x raised to minus 1. Now see here, first of all, your function is not given in a form of implicit function. That means directly it is not given in a form of function, but the derivative is given del square z upon del x del y. That means you have to consider that z is a function of x and y. So now onwards, whenever we are going to differentiate original curve x raised to x, y raised to y, z raised to z is equal to c. In that case, we are considering that z is a function of x and y, and x and y are independent variable. Okay, so since you have x raised to x plus x raised to x into y raised to y into z raised to z is equal to c. So we are going to take a log both side. So taking log both side, that will give log of x raised to x, y raised to y, z raised to z is equal to log c. Using the properties of log, multiplication will be separated by addition, and powers will be going in the multiplication of log, and that will give x log x plus y log y plus z log z is equal to log c. This is your equation number 1. Now first we are going to differentiate this term with respect to x. So if you are differentiating with respect to x, then x into log x has a multiplication rule. So first x as it is, derivative of log is 1 upon x. Secondly, log x as it is, derivative of x is 1. Then y log y is treated as a constant because x and y are independent variable. But z is not independent, z is a function of x and y. We have to consider it. Okay, so please remember z is not a constant. So here we are differentiating z with respect to x. So again you have to apply u into v. First derivative of z is del z by del x log z as it is. Secondly, z as it is, log z as a derivative 1 upon z into del z by del x. Okay, and is equal to log c as a value 0 because derivative of constant term will be 0. Now simplifying this, that will give 1 plus log x plus del z by del x into 1 plus log z is equal to 0. Making del z by del x subject, that will give del z by del x is equal to minus 1 plus log x divided by 1 plus log z. Similarly, if you are finding del z by del y, then it will be minus 1 plus log y divided by 1 plus log z. Now you have to find out the values of del z by del x, del square z by del y del x. So what we are going to do, we are going to differentiate del z by del x with respect to y. That means del by del y of del z by del x. Or you can find out the derivative of del z by del y with respect to x because both are going to be same by Clairaut's theorem. So here we are finding del by del y of del z by del x. So see, del z by del x is nothing but it is minus 1 plus log x divided by 1 plus log z. Now you are differentiating with respect to y. So 1 plus log x is constant. So minus 1 plus log x common out. And 1 upon 1 plus log z as a derivative minus 1 upon 1 plus log z the whole square into derivative of 1 plus log z is 1 upon z, and into derivative of z is del z by del y, because we are differentiating with respect to y. That's why we have already find the value of del z by del y. Now substitute that value of del z by del y, and that will give you del square z upon del y del x is equal to 1 plus log x divided by z into 1 plus log x the whole log z the whole square into the bracket minus 1 plus log x divided by 1 plus log z. So if you are going to simplify this, then your del square z upon del x del y, that will be minus of 1 plus log x into 1 plus log y divided by z into 1 plus log z the whole cube. Correct? Now you have given that at x is equal to y is equal to z. That means put x is equal to y is equal to z, and writing all terms in the form of x, that will give you del square z upon del x del y is equal to minus of 1 plus log x the whole square divided by x into 1 plus log x the whole cube. Now del square z simplifying, so square 1 plus log x the whole square will be cancelled out, and you will have minus 1 upon x into 1 plus log x. Now we have to write down this in a required form. For that we are writing this as a x into 1 plus log x whole raised to minus 1, and 1 is replaced with log of e. So it will return in the form of minus of x into log e plus log x whole raised to in minus 1. But log x plus log y is log x into y. So you will have minus of x into log ex whole raised to minus 1, which we have to prove. Correct? So this is the simple, these are the some typical examples which we have seen in today's lecture. If you have any query or any doubt regarding this topic, then please feel free to contact me. Thank you.